only have a marginal risk for severe weather for Kansas and Oklahoma, and a couple marginal risks for flash flooding, including the Plains, Southwest, Texas, Florida, and Tennessee. Good morning, I'm meteorologist Pew. Today is September 1st, 2025. So in terms of severe weather for Kansas and Oklahoma, we only have a marginal risk, and what that entails is we have a 5% chance to see winds up to 60 miles per hour and large hail, but this should be pretty isolated. In the time frames of when this is going to occur, it looks like around 5 p.m. Central Time is when they're going to start initiating. And for the Plains, you guys are already seeing remnants of convection from last night, and that's why we're seeing a lot of showers this morning and afternoon, but this should dissipate over time. But you may see a resurgence of some heavy rain around 5 p.m. Central as well. For the Southwest and Texas, it looks like things are going to start initiating around 1 p.m. Mountain Time, or that's 2 p.m. Central Time. And for Arizona and New Mexico specifically, isolated half an inch of rainfall could be a thing. But for Texas, including the South and East, it looks like isolated places could get up to 2 inches or greater. For Central Tennessee, it looks like around 3 p.m. Central Time is where we're going to see some storms start initiating, and these will be isolated as well. And for Florida, specifically the east coastline, it looks like storms are going to appear pretty much all day and all night. There might be some isolated places that may see 4 inches or greater. So why this is all happening, if we look at 500 millibars of midway through the troposphere, we can see that we still have that trough and the ridge. And in between that, we do see that there's a pocket of decent shear headed to Kansas and Oklahoma. And this is caused by a shortwave trough. And as we know with shortwave troughs, when they're associated with decent shear, they're also associated with decent vorticity, which is spin. So we have wind shear, which is going to tilt the updrafts and prolong the storms, and then vorticity, which is going to help spin the updrafts and promote more upward motion. And also, just like in the past few days, we do see some cyclonic flow in the plains, which is causing the low pressure in this area, which is why we're seeing a lot of convection. But over time, this localized circulation will dissipate. And everywhere else, there's not really that much shear, so that's why everywhere else that's going to get rain today is going to see pretty short-lived and isolated storms. Now, if we take a look at the west, we do see this ridge starting to develop and broaden. And with this ridge is bringing in high pressure, which is anticyclonic flow or clockwise flow. And we have a lot of mid-level moisture in the Gulf of California right now, and it's just going to be sucked into California by tomorrow, which is why the Weather Prediction Center has issued a marginal risk for flash flooding for both California, Arizona, and a little bit of New Mexico. Okay, now back to the plains, and at the surface, we still have that low pressure, which is coinciding with that mid-level low that we talked about earlier, which is providing all that upward motion and convection. And in association with that low, we do have a cold front going into Kansas and Oklahoma, and this is going to be heading into a very moist environment, and this is what's going to provide the surface lift. And in addition to that, if we look at satellite imagery, we can see that there is some clouds this morning, but this is anticipated to dissipate over time, which is going to provide more diurnal heating, surface heating, and more instability for this area. And from Texas to Florida, we do still have that stationary front, which is providing that constant surface lift. And for South Florida, we do have a low pressure, and we know that low pressure is a counterclockwise flow, and so it's bringing in a lot of moisture from the Atlantic to central and north of East Florida. And that's why we